So in the previous video, we started work on remapping our code, and we managed to create a locations class, and we're using a static initialization block to make sure that our data, as you can see there on line 15 and sort of down to line 41, is only actually created once. And again, we're taking the functionality out of the main class in terms of creating our locations and put it into this locations class. But it really would make more sense to read from a file rather than hard coding this in Java like this. And look, there's only a few locations in this sample, but the full game's actually got 140 locations, and the exits connecting them together are actually quite complex. So storing that information in a file is a better solution. So the first step we need here to do this is to write the data out to a file. Now the code in the static initialization block is executed when the class is loaded, and that means that all the data is going to be available by the time we're able to execute any methods in the class. As a result, that means that we can create a method, a main method, to write out the locations and exits data to files. Now, one of the simplest ways to do that is using a filewriter object. So let's give that a go. So in the locations class itself, I'm going to create a static method, a main method, as we've done before, psvm, press tab. And let's start by writing some code. So it can be filewriter lock file equals null, and I'll import that, accept that import. Lock file is equal to new filewriter. I've got a typo there that I'll fix shortly, and we'll just call the text file locations.txt, and I'll fix this so it's lock file. And we'll look at that error shortly. So for locations.values, we're going to do lock file dot write, and we do location dot get location ID plus a comma plus location dot get description. Then at the end of the for, we're going to put lock file dot close. So the code here, and again, we are going to fix those errors shortly. The code at the moment is quite simple. So it creates a filewriter object, passes the file name as a parameter to the constructor, then uses the write method to write data to a file. Then, of course, once all the data has been written to a file, the file is closed, as you can see on line 21. Now, that last step is actually very important, and failing to close streams can really cause problems such as resource leaks and locked files. So if an output file is not closed, then the data can become corrupted or the file remain locked so that no other process is able to use it. In actual fact, it's so important that Java 7 has introduced a much neater way of dealing with streams to ensure that they're actually correctly closed, and we'll actually be getting to that and using that soon. For now, though, we need to understand why there actually are errors in the code. So each line that involves our filewriter is showing the same error, and if I just hover over it, unhandled exception java.io.io exception. So I mentioned that there's two categories of exceptions in Java, checked and unchecked exceptions. They work in actually the same way, exactly the same way. The difference is that you can't ignore checked exceptions. So IO exception is a checked exception. So in other words, our code is not allowed to just ignore it. So we really have to deal with it in some way. And until we do, the program's not even going to compile. So now we know how to handle exceptions. We could just catch the exception, which will fix the problem. So let's start by doing that. So we're just going to create a try block after the filewriter variable is initialized for the first time. Try. I'm going to put all the code that's in there that we've created to write the data in the try block. And then we'll have a catch. IO exception E. And perhaps we'll put a message there to say something like in catch block and e.print stack trace, which ultimately is going to show our stack trace, the error on the screen. So that actually fixes the error and for now, and the program will actually run now. So we're going to have to right click this time to make sure we're actually running the locations.main and not running the other main.java in the actual main class. So we're actually running the main method within our locations.java. So running that. Notice now that locations.txt has been created, and we can open it in Java, in IntelliJ rather, to actually examine the contents. And if I just close down this window so we can see a bit more, you notice that there's got a location ID, a comma, and then the actual description. Then it continues on. We've got another location ID, another comma, and another description, and so on and so forth. So that's pretty much all there is to writing data to a stream. One thing I didn't do, which I should really fix now before we go too much further, is I should actually have an end of line character. So where I actually wrote the code here after the get description, we really want to go and put an end of line. So I'm going to add a plus \n as well. And run that again. That should overwrite the existing file that we've got and make it a little bit easier to look at. So now that that's finished executing, close that down, and we'll have a look at our locations.txt file, and there you go. It's a lot easier to read this time. Location ID, comma, and then the actual description. Then it moves to a new line, and then we go and we can see the other locations there. So that's it. That's pretty much all there is to writing data to a stream. The stream is opened, in this case, by passing a file name to the file writer's constructor, as you can see on line 19. The data is then written on line 21 using the for loop to go through each location that we've got, and then the stream is closed on line 23. Now there is a problem with this code though, and we have to add a little bit more complexity. So the problem is that the error in the loop that writes the data will cause the catch block to be entered, skipping over the call to the close method. So in other words, you can see on line 21, if we had some error there, it's going to skip this line 23, which means the file isn't going to be closed, and it's going to skip straight to the catch block on line 25, which we may not want. And ordinarily, when dealing with files, we wouldn't want to skip leaving a file open like that, even if there was an error. So basically, as a result, the file is not going to be handled, or properly closed, I should say. So to handle situations like this, when there's some cleanup code that absolutely must be executed, no matter what, the Java exception handling mechanism also has a finally block, and if there's an exception raised in the try block, the code in the catch block for that exception will be executed, but then, regardless of what happened, the finally block is also executed. So you can be certain by using the finally block that code in there is always going to be executed, as long as the JVM itself doesn't crash, which of course is very unlikely. So a try block itself must have either have a catch or a finally block. It need not have both, but it must have at least one or the other. So in fact, soon I'm going to be removing the catch block, and so we can just have try and finally, and that's actually quite common when actually dealing with I/O operations. So a better way to code this then would be to call the close method in a finally block. Let's have a look at doing that. So under the catch, we can put finally, and put a message to indicate what's going on. And we'll put in finally block so we actually know what's going on. And we'll remove this close that's on line 23 and put that into the code on line 28. But that then introduces another error, and if we hover over that error and have a look, we've got a Java I/O exception error. So unfortunately, close itself also throws an I/O exception. So we once again get an unhandled exception error, and then we have to wrap the call to close in its own try catch block. So we want to be very careful not to cause more exceptions in the try block. So we'll also check that the lock file variable is not null before attempting to call its close method. So let's go ahead and do that. So we're going to add a try here. Well, the catch is going to be IO exception again. And then we're going to, with the IO close, we're going to put in the try block. And what we'll do here is just to make sure that we're not going to potentially have other problems, we're going to put a test here just to make sure the lock file, if lock file is not equal to null, then and only then are we going to try and close it. And this type of defensive program really makes programming really makes sense, particularly in situations like this where you really don't want something to crash. You really want to be sort of fairly sure and fairly certain that the code is going to be as resilient as possible so it doesn't crash. We'll actually put a message in there just as well so we can see what's going on. Attempting to close lock file. Like so, then the IO exception, we're just going to do an e.print stack trace. We're not going to do anything else. We've finally seen how to write data to an output stream in Java, which is good. And we'll just run this again just to make sure that it does work. In finally block, as you can see, attempting to close lock file. We didn't get any errors. And we've still got our locations file here, and that's still been written to disk, which is good. So everything seems to be working nicely. So I've actually covered quite a lot there, including introducing the finally block. As I mentioned, that's really an essential part of exception handling. Now, up until Java 7, the code in our locations main class was pretty much the standard template for writing data to a stream, and reading from a stream looks very similar to that. But Java 7 introduced an improvement that actually makes the code quite a bit neater. But before looking at that, I'm actually going to cause an exception just so we can see the exception handling in action. Now, there's quite a few ways to break I/O code. On all three operating systems, we could set locations.txt to read only, or on Linux and OS X, we could change ownership to root. We could also specify an invalid path to a file, attempting to create the file in a disk drive that doesn't exist in Windows, or in an invalid volume in Linux and also OS X. The easiest way here, though, is just to delete the file we've just written and create a directory with the same name before running the program again. And that will actually work on all three operating systems. So let's look at doing that so we can actually purposely get it to actually come up with an error. So first thing, I'm going to come up here and just right click that and click on Reveal in Finder. Go into there, open up the location where this is, and I'm actually going to delete it. Actually, what I'm going to do is I'm just going to copy the file name, so I'm going to need that shortly. Then I'm going to delete the locations.txt. In my case, I'm going to move to trash. You'll just do whatever's equivalent on your operating system. And just to make this a little bit weird, we're going to click on File, New Folder. And you'll do the similar thing for your operating system and call the folder locations.txt. So in this case, OS X is saying, are you sure you're wanting to make the folder.txt? So it sort of recognizes that that's a problem. So I'm going to click on Add because we do want it to be a TXT file. We want it to be exactly the same. And it is actually a folder, as you can see. So you want to make sure when you're creating this on Windows or Linux that you actually are creating a folder and not just another file. So I've definitely created a folder, as you can see there. So now when we run the program, we should actually get an error because, of course, it won't be able to create a file because there's already a folder there with the same name. So I'm going to run that. And yes, we did actually manage to get an error. And you can see there it actually tells us quite clearly java.io.file.found locations.txt is a directory. So you may get something similar. You should get something very similar on your operating system if you're not running Mac OS X. The bottom line here is it's actually telling us that it can't create the file. And you can see that it was in the catch block and it also went to the file name block as well. So obviously both our bits of code were actually triggered when it came up with an error. So you might be wondering, well, why is the file not found exception, why is that being caught when we've actually only looked for IO exception in our code? Well, the reason for that is file not found exception is actually a subclass of IO exception. And as a result, it's caught by our catch block, and we can see the message, as you can see in the run window to the right-hand side in catch block printed. And of course, we can also see the final block code as well, which I mentioned. Now you may see the message from the finally block appear before the stack trace rather than after it, but that's really a result of the way that the stack trace is generated. The finally block is executed after catch. Now you may also see the message from the catch block in amongst the stack trace, but the program's output will be printed in the order it happens, but the stack trace will appear when it's good and ready, basically. So notice here that there's no attempt to close the file, because remember we had this message here attempting to close location file or lock file. That doesn't appear anywhere, so that actually wasn't attempted. And the reason that it wasn't attempted was because the lock file was set to null on line 19. Then we've got this code on line 21 trying to create a new object that failed, so therefore lock file was still null, and then consequently we didn't try and close a file that of course was never created in the first place. So you can see why it can be very useful to have this code here to test for null before trying to actually do something. Because of course if we hadn't have done that, we would have got a null pointer exception because the lock file wasn't a valid object. So before moving on, I'm just going to go back to that folder again. So in my case, I'm just going to come up here to the project and click on Reveal in Finder again. I'm going to go into my folder and I'm going to actually delete the folder, locations.txt, so that we can actually use that again. Move to trash. Do whatever the equivalent is for Windows and Linux if you're on one of those machines. If you run it again, we should find it's now working again. And our code's now working again normally. We can see locations.txt on the screen. All right, I'm going to actually finish this video here. In the next video, we're going to start out with a mini challenge. And then we're going to look at enhancing our code and using some other functions built into Java for reading and writing files. So see you in that next video.